Let me show you. Particle we're going to talk about today, and briefly the periodic table. It's very simple. You need to know that, right? So we're not going to do any calculation with atomic masses, moles, all right? That is the part that we are not doing. So periodic table is central to chemistry. Very important table. It's like our roadmap, okay? We take it everywhere we go, you know. We looked at periodic table often to summarize whatever knowledge we have. So basically periodic table is arrangement of elements in increasing atomic number in periods, horizontal rows, and vertical rows called groups, right? You have it up here and in the book. So one thing we try to do is maintain the similar chemical reactivity in a group. For example, group 1, which is also called group 1A, sometimes we call it 1A, called alkali metal. Hydrogen is outboard. Reason is hydrogen belongs, we think hydrogen is metals and also non-metal. Hydrogen forms positive ions, right? And it's a gas like chlorine, bromine, iodine. Therefore, even though it should belong alkali metal group, but it's not considered as an alkali metal. Its classification is on the first row. Hydrogen and helium, right? Stays there as, helium belongs to noble gases, but the hydrogen doesn't belong to alkali metal. So similar chemical for lithium, sodium, potassium, rubidium, cesium, francium. We take the alkaline earth metals, the second group or the group 2A is beryllium, magnesium, calcium, strontium, barium, radium, like that. So we have similar chemical properties, noble gases, helium, neon, argon, krypton, xenon, radon, fluorine, chlorine, bromine, iodine. Acetylene is not considered similar to all those, but it's in that group. We generally call chlorine, bromine, iodine as halogens, right? Then in the middle, there's a dip in the middle, in the periodic table, starting from scandium to zinc. And this whole block here is called transition elements, transition, in between, all right? We call it transition. This group is called lanthanide, actinide, and these are these groups don't have specific name, but they have similar chemical properties. So whole idea is classifying elements to show their similarity. Now, the periodic table was developed for a long period of time, right? It's not just one man's creation. There was a guy named Newlands that he came with the idea. This is the same time where the 7 planets are considered as musical notes. People were thinking music is everywhere, you know? So even now, I guess. Law of octaves. Every 8th element has similar properties. So this is kind of you might think, well, where's the 8th? Okay. Long time ago, we didn't know about transition elements. But if you count 1, 2, 3, 4, 5, 6, 7, 8, right? Then it starts with similarities. Since we didn't know about transition metals that much, So that makes sense, right? Every eighth element has similar properties in this octave. So that's the beginning. That's the periodic nature of elements that, or the periodic table. Okay, but the one that came up clearly and proposed something similar to this table. This is not Mendeleev table, right? This has been gone through many modifications, like Dalton's atomic theory being modified to accommodate new discoveries, isotopes, right? Radioactivity. So Dmitry Mendeleev, this guy, came up with the table with 63 known elements and arranged them on the basis of atomic mass. We didn't know about atomic number that time, atomic mass. So he got table with 8 groups. It's arranged according to atomic masses, just like the bottom number right now in the periodic table, that's the atomic mass. Okay, it looks like this. All right. Group 1, this is German. Group 2, 3, 4, 5, 6. All right, 8. All right. It's more complicated than now. There are a lot of elements like sodium, potassium, rubidium, cesium, silver, copper, gold in there. Now we expanded. We have a long form of periodic table. But some of the features of this group 8 groups are still kept today. I mean, always when you have a CD or landmark, you still have the historical figures there, right? So you're not inventing things very difficult to get rid of the main features of the periodic table. Therefore, remember, there are 8. Group 8 is the idea about octaves, and it still is in this periodic table. I'm going to show you in a minute. But this is a little complex. But one thing about this is, after the 63 elements were arranged in an increasing atomic number like this, he found out silicon, and there's a missing element, which should have atomic mass of 72. So he called it eka silicon. See, similar to silicon, but he didn't give a name. Okay. But what we found out after he predicted this should have 72 mass, color is gray. See, it should form elements like this, just like silicon, and all these were predicted. Now this was a triumph of the periodic table because, hey, now you can predict missing things, right? So, but the current values are given here. They're pretty close, all right? Without even knowing the element, right? So he predicted. That was very successful. I mean, that's science, okay? It can have more predictive value than your common sense. You organize things and come up with new ideas. Now the modern periodic table is different. We have atomic numbers in place of, the atomic numbers are the top number, top right number, that blue number on the periodic table, right? That's the atomic number. Then the element symbol is there. Then the atomic mass. The atomic mass in these are called average atomic mass, AMU, all right? So AMU is defined by 1/12th mass of carbon-12 isotope, right? We're going to talk about that later. So atomic, these are not grams. They could be, atomic mass units could be also called grams per mole, right? Grams per mole. Periods are horizontal rows. Groups are vertical columns. All right. Now look at this one. Now this is the remnant of still group 8. So that group 1A, group 2A, group 3A, 3B, this is B's, and group 3A's are only do you notice the pattern? The A's are for the tall groups. Yeah? A's are for the tall groups, excluding that. Tall groups are called main groups, other than the transition metals. You understand what is a main group? Where main group is an element belonging here or here, right? Okay, main groups. So main groups are labeled A's. And then keep the B's for the transition metals. We have to keep the 8, group 8, similar to Mendeleev table. Group 8 was these things on the other side if you go back and look at it. So group 8, 1B, group 1B, 3B, like that. So in the Mendeleev periodic table, copper, silver was on the first group, right? So therefore and zinc, copper was in the second group. Okay, now, but right now what you do is 1, 2, 3, 4, up to 18. That's the easiest way. How many groups are in the modern periodic table now? 18, all right. But they got those landmarks of Mendeleev periodic table, like group 8, like that. To keep everything together, they lumped it up. There should be, and these are A's and B's, like that. Okay. Now, average atomic mass units is given at the bottom of the square. Square for each square is like a Hollywood. We have a square for each element, right? So, again, it looks like Hollywood. These are the famous people, right? Lately it becomes like Hollywood, the name for borium, and berkelium, californium, Einstein, bromium, all that stuff. Okay, as I said before, group A, 1A is that one. This one called is group 1 or 1A is alkali metals, and group 2A is the group 2, that is alkaline earth metals, and group halogens, that fluorine, chlorine, bromine, iodine, chlorine is missing. Group 0 is the noble gas. Right, group 18. Right. Okay. All right. Do you see that? This is group 1 through 18, right? So this is called 1A, 2A, 3A, 4A. Main groups are called A's, right? And the transition metals are called B's, but 3 up to 7, then the 3 groups are lumped up into 8B and 1B and 2B, right? And these are transition metals. These are actinide, lanthanide, lanthanum. Starting with lanthanum, this row of element period is called lanthanide, actinide. Now periods are assigned numbers. Okay? Now if someone asks you, what is the element in the fourth period and group 3A, fourth period and group 3A. 3A is here, fourth period is there, Indian. You see that? Now you have to remember at least this is 1A, 2A, 3A, 4A, 5A, 6A, 7A, right? I'm not worried about transition metal, right? Just the other ones, all right? Main ones, all right? Now periodic table also shows non-metals here, metals here. And this area is called metalloids, in between metals and non-metals. It's called metalloids. Any element, what would be, how do you get that thing? You start here, step like that, going like this, right? So bordering elements, on that line, except the aluminum, and the bismuth, aluminum and the bismuth, everything is called including boron, silicon, right? It's called except aluminum and bismuth, the bordering element. It's not bordering. Yeah, it could have been bordering. Right. All right. You got the idea. Metalloid. And yellow squares are non-metals, and also non-metals have different chemical properties. They lose electrons, they gain electrons. Metals acquire, metals lose electrons. Non-metals gain electrons. So this is considered a non-metal. Here, hydrogen. Okay, based on the physical properties, states of the matter, there are 6, 10, 11 gases. 6, 9, 10, 11 gases. How many liquids are there? 2. Naturally, at room temperature, these are liquid. All right. Rest of them are solids. Okay. Just to keep counting, 89 are metals, 31 are radioactive, 22 are synthetic, 11 are gases, 2 as liquids. What do you mean by 31 are radioactive? Which one are the radioactive? Like after polonium, all these 86, 87, then actinium. Now the devil, that one, all right? Starting from that, then going through that. Right? Synthetic means the one in, how do you call it? These are in whole letters, these are in normal letters, right? Outline form. The outline letters are synthetic. And remember, technetium. The student affiliate of the Chemical Society think that technetium is reserved for tech. Because, but it's not existent, that's it. But it's a good element, right? Invisible element, tech, okay? So it's not existent because something happened to this odd atomic number happened to be not creating anything stable in the nucleus. So odd atomic numbers always give less stability to the elements, the nucleus. Okay. So some of them are unnamed, but right now I think some of them are named as the periodic table printed. The synthetic ones are the ones after polonium, after bismuth, with outline typesetting here. After polonium, anything greater than 8, after bismuth, anything atomic number, anything greater than 83 is unstable, right? radioactive decay. Okay, to summarize everything, okay, alkali metal, alkaline metal 1A, these three groups are called 3B, 8B, three groups here, iron, cobalt, nickel. And this group, 2B, is the end of the transition metal series, but they don't behave like transition metals because their electrons are. How many of you know, I'm just asking, in these blocks, in the valence shell, S electrons are filled. This is called S block. And in here, the D electrons are being filled, right? D electrons. How many of you know what is S orbital, P orbital, D orbital? Those are the blocks of elements, right? This is P, and this is F, all right, blocks. You're going to learn more about it in CHEM101. So right now, let's leave at it, this state. Metalloid. All right. Lanthanide, actinide. If I ask what is a copper, what kind of element is copper? What can you say about it? Transition element. It's a solid, right? Transition element. That's all you can say. Then if I pick uranium, okay? Uranium is the actinide, right? It's called one of the trans-uranium elements also. Family name. Halogen. No gas. Transition metal. Inner transition. Together, lanthanide series and actinide series is called inner transition. Transition metal is 3 electrons are filled. 4. Actinide and lanthanide, 4F and 5F orbitals are filled, inner orbitals. The F orbitals are more deep than D orbitals. Actinium series is also called trans-uranium series. Uranium is one of them. What are these transition metals? One of the elements, iron is a transition metal, right? And actinide is one of these at the bottom. Thorium, uranium, neptunium, right? Actinide series. Semi-metals, lanthanide series is one of them. Cerium, europium, gadolinium. See, one of those in the bottom, top, bottom row. Okay. Semi-metals or metalloid. Can you name a semi-metalloid? Boron. What was the one we had? Boron, silicon, germanium, arsenic. That's it, right? No bismuth, no polonium either, right? Okay. To be sure, if you pick one of these, boron, silicon, strontium, you're okay. All right. That's in the middle. Sometimes they have metal properties, metallic properties, non-metal properties. Okay, let's go do this. I will be quick. What group or family do these elements belong to? Sodium. Group 1A or group 1 or group 1A. All right? One, just one as in letter. 1A, all right? Or it's called alkali metal. Okay, group. Okay, B is group. What is the group? 2 O, 2A O, alkaline. Okay, group C is group, what group? 17, 7A. How do you write 7A in Roman numeral? Okay. Halogen. Okay, helium. Group 18, sometimes we call it 0, or group 8A, 8A, 8A. Noble gas. Okay, so it's an easy one. List 2 elements of each of the following. 2 elements. Let's main group element. What is main group? What did I say? Belong to that A, named A, right? Except they have 0, group 0. Anything 3, 1A, 2A, 3A, 4A, 5A, 6A, 7A. Chlorine is a main group element. Sodium is a main group element. All right? Okay. Transition element. One in the middle, it could be chromium, it could be copper, it could be rhodium, RH, molybdenum, MO, niobium, NB. All right. Lanthanide, cerium, samarium, europium, lanthanide. Actinide, thorium, berkelium, nobelium, lawrencium, right? Actinide. Identify the following molecules, not molecules, elements, as metal, non-metals, metalloid, noble gases, transition metals, actinide, or lanthanide. Okay. What is it? Silicon. Silicon is what? Metalloid, yeah, semi-metal or metalloid. Okay. Calcium is alkaline earth metal. Chlorine is halogen. Europium. Look in the periodic table where europium is.
Lanthanide.
Right. Europium is lanthanide. PU, I forgot the name. Okay, PU is in, oh yeah, that's the actinide. Nickel, transition, argon, noble gas. Yeah, this thing is pretty easy, all right? Which of the following are main group elements? Which? Silicon is a main group element. Why? It's in the group with the A's, right? Calcium is a main group element. Chlorine is a main group element. Europium? No. Plutonium? Right. Nickel? No. Argon?
Yes.
Yes and no, okay? Because it's in the, sometimes these definitions, okay? Main group defined as groups with A's, including the noble gas, but I think yes, right? Yes. But everything is not yes and no most of the time. We go here, yes, okay? Now atomic symbols, you understand, atomic number is written in the bottom, left bottom, here 15, phosphorus. If you have phosphorus, if you have the periodic table, you know that is 15, right? The 15 atomic number characterize the element, all right, what it is. Rest is mass number. Mass number is sum of the numbers of protons and neutrons, right? Mass number. It's a whole number. Okay. All right. In the periodic table, most of the atomic masses are not whole numbers. It is because these are average atomic masses. These are averages considering all the different isotopes with whole mass number masses, whole number masses, right? So that's why. Determine the number of proton, neutrons, and electron equivalent. This one has protons, 15. How many neutrons? 16. That means this number subtracted that number gives the rest of the neutrons. Okay, this one. Electrons. How many electrons? If you didn't write anything, there's no charge in an atomic symbol, we still write calcium 2 plus. That means it's 2 electrons are lost. So therefore, how many electrons are here? If you didn't write them charge, that means all the electrons are there. Therefore, how many electrons are in a neutral atom? 15. Number of electrons in a neutral atom are equal to number of protons, right? Charge neutrality. Okay, 56 is the proton number. How many electrons are in there? 54. How many neutrons? 82. You subtract. All right, 2. I cannot do calculus. All right, you got it. 82. All right. 92 protons, 92 electrons, 238 subtracted 6. 13, 146, right? 146 neutrons. All right. You should be able to do all these things. I think we have done that already. Atoms have isotopes are defined as the atoms of the same element having the same atomic mass but different number of neutrons in the nucleus. They have the same number of electrons, just like any other atoms of elements, right? Different number of neutrons. Okay, isotope hydrogen has 3 isotopes. Hydrogen, we call it tritium, deuterium and tritium. Hydrogen is the only one we name this as a D and this as a T. Right? We call it, hydrogen got special privileges. You know, we call it, it's different isotope, different names. Deuterium, tritium, right? Tritium is radioactive because the imbalance in the neutron-proton ratio. Isotope of carbon, carbon-12, sometimes we call it hydrogen-1, hydrogen-2 as a word, name of the element, the isotope. Hydrogen-3, or this way, symbolic form. This is carbon-12, carbon-12, carbon-13, carbon-13, 13, carbon-14. Carbon-14 is radioactive, right? Carbon-14 is used as a tool to determine the age of artifacts. Carbon is found in organic material. You burn it, you calculate how much radioactivity is produced from the carbon dioxide emanating from the sample and compare to the present day carbon dioxide C14 levels in the atmosphere. So you can get the age of material.